All right, today we're going to be starting our fourth chapter of geometry, which is congruent triangles. In this chapter, we're going to learn how to prove that triangles are congruent in a vast majority of ways. However, today what we're going to concentrate on is the corresponding figures. All right, so the first, or the congruent figures and corresponding figures. So the first thing we're going to do is define these two things. So we have a congruent figure, which is congruent figures, which are two figures that have exactly the same size and shape. All parts of one figure are congruent to the corresponding parts of the other figure. Corresponding parts are exactly the way they sound, just like anything that is corresponding. It's a pair of angles or sides that have the same relative position in two congruent figures. Now, this is very important to understand because while you're proving that things are congruent to each other, you need to be able to identify which parts are corresponding in order to figure out if they are in fact congruent. That sounds a little confusing, so I will do an example for you real quick. So we have write a congruent statement for the two triangles. Identify all parts of congruent corresponding parts. So what that means is if I were to take these two triangles and I were to figure out what the corresponding parts are. Well, I know that angle K and angle S are some corresponding parts. I know that J and angle T are corresponding parts. I know that angle L and angle R are corresponding parts. And then I can do the same thing with the sides and differentiate which ones are corresponding to each other. So just to give a quick example, I know segment JK is congruent to segment ST. All right, so in order to write a congruent statement, I'm going to write triangle, which is just a triangle, so a picture of a triangle. And I'm going to name it KJL, that first one. So KJL is congruent to triangle. Now in this case, I cannot just haphazardly name the second triangle. I do have to match up the corresponding parts. So the corresponding angle with K is in fact S. So S is going to be my first. The corresponding part to J is T. And then last but not least, the corresponding part of L is R. So that would be my congruence statement for these two triangles. All right, so in this section we have one theorem we're going to talk about. It is Theorem 4.1. It states if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So if you look at this particular picture, we have angle B and angle E, which are congruent to each other. We have angle A and angle D, which are congruent to each other. And because we have two angles that are congruent and corresponding, we can safely say that angle C, is congruent to angle F. All right. So while we are looking ahead, we often need to prove that two figures are congruent. So in order to do that, there are two steps we need to follow. We need to prove that all the corresponding sides are congruent, and then we need to prove that all the corresponding angles are congruent. Okay, so here's a quick example of a proof that we have. It says given segment AD is congruent to segment CB, and that segment DC is congruent to segment BA, and then I have angle ACD is congruent to angle CAB, And then angle CAD is congruent to angle ACB. In our particular drawing, they've already included those markings for us. So from here, we're just going to create a two-column proof in order to prove these things. So I have, if you remember, I have my statement. On one side I have my statement, on the other side I have my reason, okay? So in order to do that, what I'm going to do is then go through and highlight which ones and prove that I want to prove that these two triangles are in fact congruent to each other. So I'm going to go down the line and just list things. I'm going to say, okay, well I know AD is congruent to CB, and the reason for that is it is given. All right, again I have, which is marked up here, then I have DC is congruent to BA, and that again is given. Now, in our rules, it says that we need to make sure that all of our sides and all of our angles, corresponding angles and sides, are congruent. So what I'm going to do now is I'm going to concentrate on the side. So I've just proven that this side is congruent to this side, and this side is congruent to this side. Now I have a third side, and actually in this case I can say that segment AC is congruent to segment AC, and the reason for that is actually the reflexive property. And if you recall, the reflexive property is just stating that AC is congruent to AC, which means anything can just be congruent to itself. So in that case, we now have the three sides that are congruent. Now I can go through and I'm just going to say, all right, that can go there because of given. Same with that, that can go there as well as given. Okay, so I have my two angles. Now I need to say, well, angle ADC is congruent to angle, this angle right here, is congruent to angle CBA. And we just learned from our Theorem 4.1 that when two angles of a triangle are congruent, then the third angle of those corresponding triangles are also congruent. So I can say Theorem 4.1, or more specifically, I would just say if two angles are congruent, the third angle is also congruent. Okay, my last statement then is always my finishing statement, which is that the triangle ACD is congruent to triangle CAB, and the reason for that is because that is the definition of congruent triangles. All right, so tomorrow I'll be prepared to work on another another worksheet and some other things. We will be doing some proofs. If you want some additional practice, this is a really good proof to display the points that that we were talking about. So I would say try this at home. It's a really good practice. Other than that, see you tomorrow.